So this is the place in our notebook where we have our experiments that we run for the project. And for each PC, which is percent crossover, and PM, percent mutation, in these we loop through and we run experiments for every combination of objective function, so M1 and M4, and niching method. So run experiments, what it does is for 10 repetitions, we run the genetic algorithm, which returns our fitness statistics, which they themselves over time show the min, max, and mean fitness value, as well as the population history, which show the point locations. So we have our initial and our final, which we end up graphing for our report. And out of those 10 repetitions, we count the peaks and take the one that has the highest peak count as our representative. And then we plot our history and we plot our population. Going over the genetic algorithm, this is somewhat modified from the original version of the notebook. We start by initializing the population and the fitness statistics and the population history. Then we compute in a loop for the number of generations. We compute our fitness value, which if we're sharing, then we use the sharing method. We do the normal sharing method, except we make sure that our denominator is at least 1, therefore we don't get really big fitness values. We also implemented stochastic crowding, as you can see here, where we replace children based on similarity, and we pick randomly to replace the parents. The only other thing changed in the algorithm is we added in the niching methods, but also there was an issue before where we were only replacing one parent, and we made it so that we replace 2. It provides better results. But yeah, this just picks whatever niching method we're using. If we're using stochastic, then we do an inherent replacement in our helper function. Otherwise, we do our normal replacement. And then at the end, we compute our final fitness for the final value and return our fitness statistics. So as for the findings, one thing that was surprising was the fact that the no niching method was not terrible. It actually performed somewhat similarly to sharing. The function M1, sharing did definitely perform a little better. There are places where we can see sharing found like all the peaks here, but then the regular one didn't. But shockingly not performing terribly. Even on this, it doesn't gravitate towards the first peak like I would have expected it to. And it's good at finding some of the smaller ones. Sharing is still a little better, but that's surprising. It could be a setup issue, not sure. The other thing that's interesting is how chaotic the convergence is for everything except for stochastic. Stochastic crowding converges very, very quickly and very, very nicely, but these become very chaotic, which is interesting. And also we can see, and this was discussed in the lecture slides, but we can see that the stochastic crowding is very bad at finding the lower peaks on the M4 function, because not all the peaks are the same size, and we get this sort of replacement of the lower peaks due to the niching method. But it still consistently finds the top 2, and when the mutation factor is high enough, we actually manage to find 4 of them. But the sharing does generally do better here. The most helpful part about this project was seeing all of the code and running it with different mutation and crossover values. That really helped to get an intuitive understanding for how this works. Also, going through the code to add the different niching methods helped a lot with the understanding. The most challenging part was figuring out what the issues with the code were whenever it wasn't working properly. The sharing niching method wasn't properly working, and the graphs it produced were quite poor in quality, so I had to figure out what was going on there. Turns out it was I was forgetting to recalculate the fitness every iteration, which was a problem.